All right, let's go ahead and take a look at a series question here. Number 2 here says the Taylor expansion for a function f of x about x equals 2, that should say, is given by f of x equals, and then it goes on to give the polynomial expanded out. And then it equals the summation from n equals 0 to infinity of our nth term here. So letter A asks us, what are the values of x for which f of x converges? So to be able to test where this one converges at, we're going to take a look at our nth term here. And we're going to use our ratio test to help us go ahead and do that. So our ratio test is the limit as n goes to infinity of the absolute value of our n plus 1 term. So I'm going to take x minus 2 to the n plus 1 power all over 3 to the n plus 1 power. Now I'm going to divide by the nth term, but instead of that I'm going to multiply by the reciprocal. So it'll be times 3 to the nth over x minus 2 to the n power. So let's go ahead and start to simplify this term here. Let's start with x minus 2 to the n plus 1 over x minus 2 to the n. Division property of exponents here means that we're going to subtract our exponents, and I think we'll just be left with x minus 2 to the first. So limit as n goes to infinity, the absolute value of x minus 2, I guess we can put to the first power, all over. Now let's simplify 3 to the n over 3 to the n plus 1. Again, if we're subtracting these, the n's will subtract out, and we'll be left with n to the negative first, or 3 to the negative first, or just 3 to the first in the denominator. Now we can go ahead and compute our limit. So let's go ahead and compute our limit as n goes to infinity. There are no terms of n, so this is just going to equal the absolute value of x minus 2 over 3. And because this is a ratio test, we want to go ahead and we want our ratio test will converge when we are less than 1. So I want to have the absolute value of x minus 2 over 3 is less than 1. Now, this 3 is just a constant, so I'm going to factor that out front so I can end up with 1/3 the absolute value of x minus 2 is less than 1. And I can bring that out because 1/3 will always be positive. Okay, it doesn't matter if it has the absolute value around it or not. If we're solving for x, I can multiply 3 to the other side. Absolute value of x minus 2 is now less than 3. And we have an absolute sign that is less than a constant. That means we can write an extended inequality where negative 3 is going to be less than or equal to x minus 2, which will be less than the positive version of 3. And we can say that that is, if I add 2 to everything, I can say negative 1 will be less than x, which is less than 5. So we can see from our ratio test that from negative 1 to 5 over the open interval, our series up here will converge. Now, we're not done yet. Ratio test, when it equals 1, is undetermined, or we need to do some further investigations. So we need to test the endpoints. So I'm going to take x equal negative 1 and x equals 5, and I'm going to substitute those in for the value of x up here in our summation statement. And then I'm going to test those to be able to see if those individual points make this converge or diverge, this series converge or diverge. So let's go ahead and start with x equals negative 1. So that means I'm going to rewrite my summation from 0 to infinity. If I let this be negative 1 minus 2 will become negative 3 to the nth power over 3 to the nth power, which, because we're to the same power here, I can say that this is the summation from 0 to infinity of negative 3 over 3 all to the nth power, which I think simplifies to negative 1 to the nth power. Now, as a series in and of itself, this is just going to oscillate from -1 to +1 as you get continual value, or as you progress for values of n. So I guess we could call this the limit as n goes to infinity of -1 to the nth is not going to equal 0. Therefore, diverges by nth term test. So x equals -1 does not converge. So I'm not going to add the equal to sign to my extended inequality down here. Let's go ahead and do x equals 5 now. X equals 5 is now the summation from 0 to infinity still. Now when I plug 5 in up here to my nth term, 5 minus 2 in the numerator will become 3 to the n. And 3 to the n over 3 to the n, it's really just 1, right? I guess we could call it 1 to the n. And again, if I'm taking the limit as n goes to infinity here, this is not going to go to 0. So therefore, this will diverge by the nth term test as well. So our interval excludes the endpoints of -1 and +5, and our values of x are just the numbers that lie between those. Ratio test. All right, let's go ahead and try letter B. B says find the first 3 non-zero terms and the general terms for f prime of x. And then we're going to use that f prime to estimate at 2.1. So let's go back up here. Our series is f of x. And in letter B, they just want us to find f prime of x. So I'm just going to take the derivative of the expanded term, and I'm going to make sure that I have the first 3 non-zero terms. So let's go ahead and start that. F prime of x will be, f of x starts with 1, derivative of 1 is 0. That is not non-zero, so I can't use that. Derivative of 1/3 x, maybe I can, nope, I'm not going to be able to get this. Go ahead and take a look at your page for f of x. I'm just going to do this verbally as we compute our derivative. Derivative of 1/3 of x minus 2 is going to be 1/3. The next term, 1/9, x minus 2 to the second power will become plus 2/9 times x minus 2 to the first. And our chain rule piece is just times 1, right? It's x to the first inside. There's 2 non-zero terms. I need a third, so I'll do the next one. So 3 times 1/27. I think it can be reduced to 1/9, x minus 2 to the second. And again, our chain rule piece is just 1, so I don't need to write multiplied by 1. Now, that's just f prime of x, and we want to use these first 3 terms to estimate the value of 2.1, or f prime of 2.1. So f prime of 2.1 is just going to be 1/3 plus 2/9 times 2.1 minus 2 plus 1/9 times 2.1 minus 2 squared. And simplify to your heart's content. I am content now, so I'm going to move on to letter C. All right, let's jump down to letter C. Letter C. Introducing g of x. It says let g of x be the second degree Taylor polynomial for f of x. So f of x, we were given as the expanded polynomial for the series up here. Now I want the second degree Taylor polynomial for this. So I'm just going to go ahead and I'm going to copy those down. So f of x here, we start with 1 plus 1/3 times x minus 2, first degree, right? Plus 1/9 times x minus 2 squared. X to the second would be our second degree polynomial. And this problem starts off by saying let g of x equal the second degree polynomial for f of x. So we can say that this is g of x. Okay? So that's the first little clause there of the thing. Let's continue reading. And let h of x be the function such that h prime of x equals g of x. So here's the g of x again, right? And we're introducing h of x, but we know g of x and h prime of x are the same. So again, out front here, I'm going to put h prime of x. Now, if h of 3, original function for h, equals 0, find h of x. Well, h prime, which is g, which is f, of this polynomial, we want to antiderive h. So I want h of x equals, and I want to just take the antiderivative of this. Antiderivative of x, 1 is x. Again, since our chain rule is just 1 here, I think that I can add 1 and divide by the new exponent. So I think it'll be what? X minus 2 squared. Dividing by 2 is like multiplying by 1/2, so this will be, I think, 1/6 plus x minus 2 to the third, right? Adding 1 to the exponent. Dividing by the new exponent is like multiplying by 1/3, so plus 1/27. Plus some constant, because we're taking an antiderivative. Now, that's where the initial value is. We can plug in 3 for x and 0 for the output. So 0 equals 3 plus 1/6 times, I think 3 minus 2 is 1 squared, plus 1/27 times 1 cubed plus c. So let's go ahead and, how messy do we want to make this? I guess we could get these in terms of, 54 maybe? 6 doesn't go into 27, so 54. I'm just going to subtract it over. We'll just make this easy. Let's just go -3 minus 1/6 minus 1/27 is our constant. And just for simplicity's sake, that'll allow us to say that h of x is x plus 1/6 times x minus 2 squared plus 1/27 of x minus 2 cubed, and then plus our constant, so -3 minus 1/6 minus, getting off the screen there, minus 1/27. And there's h of x. If you have any questions on any part A, B, or C of this problem, please reach out, send me an email, let me know. We'll have another series video for you tomorrow, and then we'll get into some FRQs later on in the week.